talk about the trigonometric ratios. This lesson is going to combine two sections, 9-1 and 9-2, into one lesson because I really feel they need to be addressed together, not separately as it shows in the book. So let's get started. We're going to talk today about the three trigonometric ratios that we are going to use in this course: sine, cosine, and tangent. And you should learn how to determine side lengths in triangles using these trigonometric ratios. So first, let's talk about parts of a right triangle, because we're dealing here mainly with right triangles for right now, okay? So parts of right triangles. And we know we have a right triangle, we have a right angle, right? And then the other part that's opposite that is our hypotenuse. And that's this side. Now the other two sides we're going to label opposite or adjacent, depending on what angle we are looking to try to find the angle of. Since we know this is a right angle, we know this will always be 90 degrees, right? But we don't know what the other two angles will be. Okay, so when we are dealing with this, we will see what angle it is we're dealing with, first of all. So let's say we're dealing with this angle right down here. The side opposite this is going to be the angle that this opens up into, which is this. So we're going to label this opposite. I need to be able to spell here. Opposite. And the side that helps form the angle, we will label adjacent. Okay. Now, if we are talking about a different angle, say we want to talk about this other angle up here, this angle here, then the side that it opens up into will be labeled opposite, and the one that helps form it will be adjacent. So the opposite is the side the angle opens up to. And the adjacent side is the side that helps form the angle. With the hypotenuse. And the hypotenuse is always opposite the 90-degree angle. Okay, and we know that. Okay, so opposite and adjacent sides change depending on what angle you're talking about. Now let's talk about the ratios of side lengths in triangles. Okay, so I'm going to label these side length x, y, and z. If I'm looking to find ratios of side lengths to each other, and I'm going to start with x, I could have x over y. I could have x over z. I could have y over x. I could have y over z, right? And I could have z over x or z over y. Let's see. X over y, x over z, y over x, y over z, z over x, z over y. Okay? So these are the three ways of showing. There's 6 different combinations. And this x, y, and z stuff is not really important, just to see that, hey, there's 6 different combinations. So now let's look at the 3 basic ones. Okay, so we have a right angle here. And I'm going to use this side x, right? So I want the 3 basic ones. So opposite for this angle x is going to be this side. Adjacent is going to be this side. And then, of course, we have the hypotenuse here. Sorry about that phone call that interrupted me. So sine we're going to define as opposite over hypotenuse. Okay, so O over H for short. Cosine is going to be the adjacent side length divided by the hypotenuse side length, so A over H. And tangent is going to be opposite side length over adjacent side length, so O over A. Now, nifty way to remember this is the acronym SOHCAHTOA. Okay? Sine is our opposite over adjacent. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's the acronym that you need to remember in order to remember the side combinations for these three basic ratios. So remember, sine is opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, right? So three trigonometric ratios, and I want to do that with x equal to this angle right here. Okay? So sine is going to be opposite, which is 12, over 13, which is hypotenuse. Cosine will be adjacent, which is 5 over 13, right? And tangent would be 12 over 5. Okay? If we were doing this with a different x angle, right, then these would change. Okay? So this is, we'll call this x. So sine of x, cosine of x, tangent of x. Let's call it y. So sine of y would be 5 over 13. Cosine of y would be Okay, so here we're given a triangle, and all we have for this triangle is 35 degrees and a 15 unit measure. Let's call this 15 inches. Okay? And we need to find the length of this side here. So what we can do is we can use our trig ratios to set up a ratio that allows us to find out what is the measure of that side. Now, we have 35, we're looking to find its opposite side, and we're given a hypotenuse. So if we think sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So sine is the ratio that we want to use. So we can set this up as sine of 35 degrees equals the opposite side length, which is x, over the hypotenuse side length, which is 15. And then we can cross multiply, right? So x should equal 15 times the sine of 35 degrees. And we can just key this into our scientific calculators at this point. So 15 times sine of 30 should give us a side length of x equals, not 30, 35. 15 times sine of 35, and that should give us x equals a side length of 8.6 roughly inches. Okay, so x will equal 8.6 inches. Now, because this is a right triangle, we could use our Pythagorean theorem to find this remaining side length if we needed to. But using trig ratios allows us to find side lengths in right triangles where all we know is one side length and an angle measure. Okay, so remember, we couldn't use the Pythagorean theorem with just those two pieces of information to find any other side lengths. Another example. Here we also need to identify our trig ratio that we could use to find this missing side length, because all we're given is a 40-degree angle and a 3-foot measure of this side here. Okay, so if we're looking at this angle, 3 is our opposite side length, and x is our adjacent side length. So if we remember, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Which of these should we choose? Well, tangent makes most sense here. So the tangent of 40 degrees would equal my opposite side length, which is 3 feet, over my adjacent side length, which we don't know. Okay, so now we can solve this again with cross multiplication. So x times the tangent of 40 degrees should equal 3 feet. dividing up both sides by the tangent of 40 degrees to get x by itself, we'll get x equals 3 feet divided by the tangent of 40 degrees. So 3 divided by, again using your scientific calculator, that will give us a side length of 3.6 feet. Now, you see another reason that we want to use these trigonometric ratios, because again, we don't have a nice, neat, special right triangle type angle here. We have 40 degrees. We don't know anything about triangles with 40-degree angles. There's no real pattern to them. Well, the pattern is in these trig ratios. And so this makes sense, though, because 40 degrees is pretty close to 45 degrees, in which case our legs would be about equal. So 3.6 is nearly equal to 3 feet, and 40 degrees is just a little bit off of 45. Okay, sometimes you have the situation where you know a couple of your leg lengths, but you don't know any of the acute angles of the triangle. So you don't know either this angle or this angle. And what we have are inverse trig functions that allow you to calculate this angle measure. Now, if you notice on your scientific calculator, they're usually accessible right above your sine button. So if you look at your sine button, it'll say sine to the -1. Or above your cosine button, it'll say cosine to the -1. And above your tangent button, it'll say tangent to the -1. These are the inverse functions, and they allow you to find angle measurements instead of side lengths. Okay? So here we have a situation where we have a triangle. We know this side length is 15 feet. This side length is 35 feet. We want to know this angle. So remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and we have an adjacent side length to that angle, right? And we are having a hypotenuse. So we're going to use cosine. Now, what we have here is a situation where we have cosine of some angle x should equal 15 feet over 35 feet. Okay? That's all nice, but we don't know what x is. Okay? So what we can do is we can take our inverse cosine function and we can take the inverse cosine of both sides. Okay? So we're going to take the inverse cosine of the cosine of x should equal the inverse cosine of 15 over 35. Now the inverse cosine of the cosine of x is just x. And that's probably going to be the most difficult thing for you to get through, because there's no math that I can really show you that you would understand to allow you to see why that is. Just know that it is. Okay? So the x is going to equal then the inverse cosine of 15 over 35. Now, let me make a little bit more room here. How we're going to enter this into the calculator. You're going to hit your shift button, the second button, it's the blue button, it accesses the blue functions, and you're going to see that cosine to the -1 come up. And then you're just going to put in 15 divided by 35 and hit equals. And you're going to get that x is equal to 64.6, and this is degrees. And it's very important that in your calculator you are in degree mode, and you should see a little DEG somewhere on your screen. Okay? So that means that this x is 64.6 degrees. Okay? And that allows us then to find this angle if we need to, this other angle up here, because we can subtract that from, and 90 degrees from 180 to get that angle. But as you can see, that's not even an even angle measurement. So we're going to get some crazy numbers don't be afraid of the fact that you get decimals for some of these answers, okay? That's to be expected with this. What we've learned how to label the basic triangle parts for opposite, adjacent, and hypotenuse. We've learned our 3 basic trigonometric ratios and how to calculate missing side lengths with them. Okay? We've learned that what the inverse functions are, how to find them on our calculator, and then how to calculate missing angle measurements using our inverse trig ratios. That's it for today.